Hello everyone! I changed my audio and video setup just a little bit to kind of improve on the lighting, and I also kind of like moved everything over to the side so maybe you can kind of see the board a little bit better. Let me know if this works for you. If you'd rather have me go back to the other way I was doing things, just let me know. So today's kind of lab instructional video will be a lot easier than last time's. You won't have to hear me drone on as much as before. And hopefully a lot of this stuff, at least in terms of the theory, should be reviewed. So what are we doing today? Well, what we're doing is we're starting off with a sample of matter, and like most samples of matter, it's going to start as a mixture, okay? So we are going to start with some matter. It turns out that our sample of matter is a mixture of three different things, right? And so I'm going to kind of reproduce that chart that we saw, and probably I'll put it as kind of like a picture in a picture down here just to remind you of what I'm talking about from last week's lecture. But most matter is a mixture. And if you remember a little bit of this diagram, in between mixture and then the substance, right, the three substances that this mixture is made of, we had this really important word, which was physical method, or methods, right? So the way that we take a mixture and separate out each individual substance is with some kind of physical method. Substance is. So this lab is going to employ a whole bunch of different physical methods, right? Keep in mind that there's a difference between physical methods and chemical methods. Physical methods are kind of the more simple methods, things like decanting, which is a fancy way of saying pouring one thing away from another thing. Things like filtration, things like distillation, where you kind of boil one thing away and then leave behind something else. All of those things are examples of physical methods where we're not actually going to change the substances at all. We're just going to take each individual component of that mixture. We're going to use some sort of physical property to then separate it into its component substances. So I'll just kind of do a little flow chart of the different steps we're going to do, highlighting some of these physical methods to take this mixture of three things that at the end we should end up with three separate bits of matter. At the start, we're going to have a mixture of iron, sucrose, and sand. All of those are substances, right? So these are the three substances that are present in our mixture. By the way, this is solid, obviously. And we're going to use some sort of physical method to separate each one of these. So the first thing that you have to do is you have to use your balance and figure out the mass, your starting mass at start of your mixture, right? That's an important step because everything else, like all the percent composition that we calculate at the end, is going to depend on you knowing how much of that solid you used at the start. So follow the instructions. I think it's pretty straightforward. It might be like doing your taxes on a really boring tax form, but you'll get the idea. So as we go through this thing, well, first of all, I should probably mention the chemical symbols for each one of these, just in case they happen to be in the lab. First of all, iron, if you looked it up on the periodic table, is abbreviated Fe. So that is an example of an element once we've got it all separated. Sucrose is a little bit more complicated. It's got a whole bunch of carbons and hydrogens and oxygens in it, all kind of glommed together. This is an example of a covalent compound once we've got it separated into a substance. And then this sand, believe it or not, is silicon dioxide. So if you happen to see any of these are just kind of like the symbols that represent these much more understandable words. And honestly, instead of putting sucrose, I could have put table sugar. That's all that that is going to be. So the very first thing we're going to do, the very first method, is a physical method, right? So you'll look at this and think, well, one of those is not like the others. And you notice that iron is just hanging out there. And iron has this really awesome property of being what's called ferromagnetic, in other words, magnetic. So you're going to chuck a magnet in there and all the little iron is going to glom onto that magnet. So that's the way that we're going to separate that thing, right? And so through this physical method, utilizing magnetism, right, we're going to separate out the iron. So good news. That means that over here in a container somewhere, I've got this iron solid, and I'm going to take its mass. Mass of iron. And what we're going to do, and I'll show you exactly how to calculate this at the end of this video, is we're going to take the mass of that iron, divide it by the mass that we had at the start, multiply it by 100, and that's what's called the percent composition. In other words, how much mass, or how much of the mass at the beginning was due to the presence of iron, right? It might be 40%, it might be 80%, it could be 5%, but I'll show you how to do that calculation after we kind of go through exactly how we're going to do all this. So, good news is, we just did our lab, and we've gotten rid of all the iron. Now that has used some sort of physical property to separate out the iron. Now we've got essentially sugar and sand. So what we're going to do here, the very next step after we've kind of gotten this thing magnetically dealt with, we're going to, let's just put sugar plus sand in our mixture. And as you might have noticed if you've ever gone to the beach, sand doesn't dissolve very well in water, right? And so that's what we're going to do next. We're going to add some water, and you might have to do it several times, and I'll just be cool here and put H2O, right? Add H2O. And you might be saying, well, crap, man, that's going to make even, bigger mixture. Well, of course, what we're going to do is we're going to dissolve up all the sugar with water, leave the sand alone, we'll let the sand dry somewhere, and then the good news is all that we're left with is sugar. So we've got a aqueous sugar solution over here. Aqueous is just, remember, the fancy way of saying dissolved in water. And then over here, we've got sand that we can eventually dry. And we could measure the mass of dry sand. Right? Or dry SiO2. I'm not even sure if you can see that. Hopefully you can. And of course, once we've gotten to that point, right, we really could add up both of these numbers and figure out how much sugar was there. And I can't remember if it's in your lab or not, but usually what you do is you take this sugar solution, and yes, you can figure it out by difference, right? By subtracting the values of both of these from the mass at the start. But it's probably a good idea, if it's in your lab, to boil this, which is really distillation, right? You're going to distill the water away because you don't want the water to be there. And then eventually what you would end up with, if this is part of your lab, is this dry sugar. And of course you could take the mass of this thing. So that's the way that we're going to separate these three things. At the end, the values that you care about are the mass of your iron, the mass of your dry sand, and if it isn't actually in your lab, like I said, I can't remember, and I'm too lazy to read the thing, is to figure out the mass of the sugar. Okay? And so you've got really 4 different values that you care about. The total mass at the start in grams, the mass of the iron in grams, mass of the dry sand in grams, and assuming you do this part, the mass of the sugar in grams. And let me show you in the next little video segment what we're going to do with those numbers. Okay, so this is going to show you how to calculate the percent by mass of each mixture component. Yada, 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 what we end up with at the end should add up to somewhere near 100% if we've done everything correctly. And what you're going to do is you're going to take the total mass of whatever your sample is in grams, and then over that number, you're going to be putting the mass of a particular component. So let's say that we want to do the mass of iron, right? So the percent composition of iron. So we'll put the mass of Fe in grams. We're going to divide that by the total mass that we had in the beginning. We're going to multiply that by 100. And what that will finally give us is the percent by mass of iron in the sample, right? Super straightforward calculation, and if we wanted to figure out the percent by mass of sand, you would put the sand number up here, use the same number down here, multiply it by 100. If we actually isolate out the sugar, then it would be the mass of the sugar divided by the total mass in grams, etc., etc. So hopefully this real quick video helps you guys out a little bit. If you have any questions, I know a guy.